Hello, welcome to today's video where we're going to be looking at Surds. I'm assuming you have already seen Surds before at GCSE, but you need to still know them at A-level, and I know it's one of those things that some people tend to neglect, so let's give you a quick little reminder of those things. So first of all, what do we mean by surd form? Well, it's basically a posh way of saying simplifying square roots, so they're in the simplest possible format for them. Why do we care about doing that? Well, a good example for that would be if you're given something like square root of 2 plus the square root of 8. The problem is, if you've just been given this as a sum to do, you're probably going to look at it and go, what? How am I meant to combine these? They both look horrible because they are. They're both really horrific decimals. However, if we put the root 8, the bigger one, in surd form, we fully simplify it, then suddenly the addition or sum becomes a lot easier to do because root 8 is secretly in surd form 2 root 2. And that means that therefore in this case, if I got one lot of root 2 plus 2 lots of root 2, that means in total I've got 3 lots of root 2. So you can see why having simplified the root 8 was useful and helpful. But how do we do it? Well, it all comes down to actually index laws. A reminder to go back and watch my video on index laws or indices, because this is an index law I mentioned in that video. So if you have something times by something else in brackets to another power, that is the same as doing that power to both individual things. Only works if there is a multiply in between the A and the B, not if there's a plus or a minus. So, therefore, that is useful because a reminder, of course, that square root of something secretly means that thing to the power of a half. And so, therefore, any index law that works with indices also works with surds, because surds, reality, are a power that we just don't write as a power sometimes. We just have different notation for it. So therefore, if we look at a particular number that's inside a square root and realize it can be written as something times by something else, then we have ways of doing stuff with it. However, you do want to pick which number you split something up as very carefully, because in some cases it's not going to be in your interest to split it up in certain ways. So for instance, if I have the number 50, if I'm trying to do root 54, for instance, you are not going to want to split this up as, let's say, 18 times by 3. Because although that would be true, 18 times by 3 is 54, that's not going to give me any sort of good way of being able to simplify it. What you want to be looking for instead is your original number that's inside the square root. You want to be viewing that as a number times by a number that you know is a square number, because that is a number that will square root nicely. So instead of doing 18 times by 3 to replace the 54, I'm going to replace the 54 with 9 times by 6. And the reason I'm doing that is because, as I said, we want a square number, and 9 is a square number. 6 isn't a square number, that's fine, not both numbers. Both numbers don't have to be square numbers, but one of them. You just want one of them to be a square number, preferably. Because once you've done that, by the index law we wrote up here, therefore we're allowed to rewrite this as square root of 9 times by square root of 6. We're allowed to square root the individual things. And that therefore means that all of a sudden, actually, we can simplify this thing in a very nice way, because the square root of 9 comes to something very nice. It is just 3. The root 6, that doesn't simplify, that's okay. We've simplified a bit of it, and that's just enough to make it nicer to deal with. So root 54 gets written as 3 root 6. Showing you another example, we could have, let's say, root 27, and again, you would realize that is root 9 times by 3. And therefore that's root 9 times by root 3, and therefore this is 3 root 3. But I'm picking all my examples involving 9 so far, so let's pick a different example that uses a different number. Let's say we have, I don't know, root 80. Root 80. Now, 80 is 8 times by 10, but 8 and 10 are not square numbers. So instead, you might know that 80 is 16 times by 5. And again, I'm picking that because 16 is a square number. So that means when we decide to square root the 16, after splitting it up first, square of 16 is 4, and that will mean we have 4 root 5. Okay, that's the basic idea. What else do we need to be able to deal with? Well, Maths A-level is helpful if you also can deal with this stuff when it comes to powers. So, for instance, it's worth pointing out you might need to write, let's say, what should we do? Let's do 2 to the power of 5 over 2. And you might want to write this in surd form. So, what's going on here? Well, there's a few different ways you can look at it. One way you could look at it is to realize that there's the index law, x to the power of a to the power of b results in you multiplying the powers together. Now, 5 over 2 is secretly 5 times a half. So you could choose to write this as 2 to the power of a half, then to the power of 5, and therefore then work it out that way, just by realizing we're doing root 2 times root 2 times root 2 times root 2 times root 2. However, obviously that, writing that out and simplifying might take a while. Another way you could do it is you could realize it's 2 to the power of 5 square rooted. So if you write this as 2 to the power of 5, work that out, then you'll have one big number, which would be 32 to the power of a half. And then you could simplify it further on using the skills we're looking at in the video above. So that's another way you could do it. However, another way you could do it is you could use index laws in a different way to split it up. You see, 5 over 2 is a fraction that's a top-heavy fraction, and that means it could be rewritten as a mixed number. We're not going to do that per se because mixed numbers are things we generally try to avoid in Maths A-level, but we're going to do something very similar to it. Because 5 over 2 is 2.5. That means the 5 over 2 could be rewritten as 2 to the power of 2 plus a half. 2.5 is the same as 2 plus a half. So therefore, we have rewritten the power by splitting it up in this way as something plus something else. That's useful because now we've got the half isolated, which is important because we know the half is the bit where the square root comes from. And also the plus in the power also means we can use another index law, which is that we can write it as two things multiplied together with those two separate powers. So therefore, we could rewrite 2 to the power of 2 plus a half as 2 to the power of 2 times by 2 to the power of a half. That's useful because 2 to the power of 2 is 4 and 2 to the power of a half is root 2. So therefore, that's a way of writing that in surd form. Cool. But what about if fractions are involved? Not in the power, I mean just fractions in general. Well, one thing you sometimes have to deal with is what happens if you're trying to find the square root of 1/2. Well, another sort of application of the index law we looked at earlier is ab to the power of n equals a to the n, b to the n. A byproduct of that index law is that if we've got a fraction, it's also true for that. And the reason why it works for the fraction as well is just because fractions are just effectively a special way of writing division. And division and multiplication are so strongly linked to each other. Not all, but a lot of the things that work with multiplication do work with division as well. So therefore, square root of 1/2 is the same as square root of 1 over the square root of 2. Which means we can simplify it a bit because we've got 1 over root 2. However, we do not like having square roots on the bottom. So how to remove square roots from the bottoms of fractions? Or denominators would be another way of putting that. So here's how you do it for very simple scenarios. If you have a fraction of this form, where you've got a number divided by another number, lots of a square root, what you can do is you can take that fraction and you can choose to multiply it by whatever square root you see on the bottom. You're going to choose to multiply the fraction by that square root on the top and the bottom. Sorry, in words that sounded dreadful, but hopefully you can see it from what the formula I've written here. Now, the reason you're allowed to do that, because at first it looks like we've done a legal move. We've taken a number that we had and we didn't like and just gone, I'm going to multiply it by something else. And normally you're not allowed to do that if you don't like a number, because then you've changed the value of the number. In this case, we are allowed to do it though, because we're doing the same thing to the top and the bottom of the fraction, which is a rule we're allowed to generally do when simplifying fractions. But also, the reason why that rule works is just because if you're timesing the top and the bottom by the same thing, you must remember any fraction that's got the same thing on the top and the bottom is secretly the number 1. And we know that multiplying anything by 1 is the same as the original number. So, putting this into a couple of examples, let's say we've got 2 over root 5. We see the square root on the bottom and we go, well, you know what? Let's get rid of the square root by multiplying. Sorry, let's get rid of that. Let's multiply the top and the bottom by the square root, in this case, the square root of 5. So therefore, this will equal 2 root over root 5 times by root 5 over root 5. That will get us on the top 2 times by root 5, which doesn't really simplify, so it will stay as 2 root 5. But then on the bottom, root 5 times by root 5, well, that will just leave us with 5. A way of looking at that is root 5 means 5 to the power of a half. So it's 5 to the power of a half times by 5 to the power of a half, which by the index law we said earlier is the same as doing a half plus a half, which is 5 to the power of 1, which is 5. Everything in maths, by the way, happens for a reason. So if you're ever questioning why something happens, do ask your teacher. It's important to always, be aware why things work. Everything links up in the end. Anyway, therefore, 2 over root 5 is 2 root 5 over 5. What happens if it's slightly more tricky than that? What happens if we have 6 over, let's say, 3 root 7? What would you do in that scenario? Well, same sort of thing. The number on the top is not an issue. The number that's not inside the square root on the bottom isn't an issue. The only bit that's the issue is the square root of 7. So to get rid of the square root of 7, times by the top and bottom by root 7. So doing that, the top becomes 6 root 7. And then the bottom becomes 3 root 7 root 7. Careful though. The root 7 and the root 7 combine to make 7. And therefore, as it's 3 lots of that, that's 3 times by 7. So therefore, we have 6 root 7 over 21. Now, admittedly, I've suddenly realized this was a terrible example in some ways because it was a silly fraction. I could have just simplified the top from the beginning as 2 over root 7. But still, the same logic would apply if those numbers couldn't be simplified. But anyway, in this case, that has led to a fraction that can be simplified partly because of what I said earlier. So 6 over 21 can then be simplified to 2 over 7. So it's 2 root 7 over 7 is the final answer. As I said, bit of a silly example because of the 6 over 3, but yeah, the structure of that problem would stay the same. However, there's one extra layer we can add on top of all this, and that is what happens if the denominator looks a bit more complicated. What happens if we have a 5 over 7 minus, let's say, root 4. No, not root 4. That's a terrible example again. Let's say root 11. Sorry, I'm doing this sort of a bit on the spot. Cool. Anyway, 5 over 7 minus root 11. We don't like this fraction because there's a square root on the denominator. That's not a nice place to have the denominator. However, we can get rid of that square root. But we can't do the same trick we did before. If you try to multiply the top and the bottom of this fraction by root 11, then you will remove the root 11 from this place, but what you'll do is you'll move it to a different place. You'll end up having the 7 also being multiplied by that root 11, so you'll get a 7 root 11 on the bottom. So that's still not solving the problem. We still have a root 11 on the bottom if we choose to do that as the strategy. In other words, that's a bad strategy. So instead, what you have to do if you're trying to find a rule, if you have a fraction of this type, what you've got to do is you've got to times the top and the bottom by whatever you see on the bottom. The number that's whole will stay the same, but then whatever square root you have on the bottom of the fraction, still going to use that same square root, but if you have a plus, you'll now multiply by times top and bottom. However, if you have a takeaway on the bottom, what you end up doing is multiplying by positive top and bottom. So c plus root d over c plus root d. Either way, you're still having to multiply the top and bottom by the same thing, and that's therefore worth hammering home. But what changes is whatever you see in the denominator, change the plus to a minus or vice versa, and that's what you multiply top and bottom by. So for our example, 5 over 7 minus root 11 will become 5 over 7 minus root 11 times by 7 plus root 11 all over 7 plus root 11. What you've got to do after that is be very careful doing multiplying out. If necessary, well, not just if necessary, you probably should do it by multiplying out brackets, I should say. So therefore, we'd have what I've already written on the top, and then on the bottom we'd have this. And then we have to properly multiply the brackets on the top and on the bottom. So on the top, 7 times by 5 is 35, and then plus 5 times root 11, which is 5 root 11. Cool. On the bottom, we're going to have to do a lot more multiplying out. We're going to have 7 times by 7, which is 49. We're going to have the 7 times plus root 11, which is 7 root 11. But then we're also going to have minus root 11 times by 7, which is minus 7 root 11. And then lastly, minus root 11 times root 11 is going to be a minus 11. Minus times a positive is a negative, and then the root 11 times the root 11 makes the 11. Cool. That's helped because it's meant we now can simplify the denominator into something much nicer. We're still going to have the numerators 35 plus 5 root 11, but on the bottom we've got the 49 take away 11, simplifying to a 38. And then the 7 root 11 take away 7 root 11 will just mean we're losing the square roots, which is the whole point of what we're trying to do. So it's always worth pointing out, if you still have a square root on the bottom, you've done something wrong. So therefore, it's worth pointing out the final answer for this, properly fully splitting it up, would be to split it up as the whole number part, which would, well, not the whole number part, the bit without the square root, I should say, and then the part with the square root as a separate fraction. So 5 root 11 over 38 separately. The reason I was allowed to split the fraction up in that way is because there was a plus, and it would be the same if it was a minus, on the top of the fraction. If there was a minus on the bottom or a plus on the bottom, you wouldn't be able to split it up. It's only pluses and minuses on the top of fractions that allow you to split them up in that way. This can then be applied to a more crazy example. So let's do one more example. We could have, let's say, 6 minus root 5 all over, what do we want to pick? We'll pick 7 plus 2 root 3. Okay, so how are you going to simplify this? Well, you take the original fraction, and then you choose to multiply it by whatever you see on the denominator. So we have a 7 and we have a 2 root 3. But then whatever symbol is in between the numbers, flip it around. Last time it was a minus, so we made it a plus. This time it's already a plus, so we now make it a minus in between the two things. Cool. Multiply it out. That means you are going to have to make good use of brackets on the top and the bottom this time. So writing that out like that. And then, therefore, fully multiplying the brackets, we'll get 7 times by 6, which is 42. 7 times by root 5, which is minus 7 root 5. We'll have a minus root 5 times by minus 2 root 3. Oh, that's not very nice, is it? But minus times a minus is positive. We got the 2 times by no other whole numbers, so it's still going to be a 2. And there's a root 5 times by root 3. Now, you can combine that into one big square root. In that case, that would be reversing effectively what we were doing earlier. Root 5 times by root 3 is the same as root of 5 times by 3. So that is root 15. Cool, that's the top. Doesn't look very nice. That's fine. We're fine with square roots being on the top. It's the bottom that we don't want the square roots. And this is where the real magic happens. We're going to have 7 times by 7, which is 49. We've got 7 times by minus 2 root 3, which is minus 14 root 3, because the 7 times the 2 makes the 14. And then we're still multiplying that by root 3. Then we have 7 times by positive 2 root 3, so that's positive 14 root 3. We can already see those things are going to cancel out, so therefore that's good news. But then the 2 root 3 times by minus 2 root 3 is going to be a minus, because it's a minus times a positive. The 2 times by the 2 is 4, and then the root 3 times by root 3 gets us 3. So do be really careful about that sort of stuff. So just rewriting out there what I was doing there. 2 root 3 times by minus 2 root 3 is the same as 2 times by minus 2 times by root 3 times by root 3. The reason you're allowed to do that, by the way, is because multiplication doesn't matter what order you do it in. So as everything means multiply 2 root 3 means 2 times by root 3, so on and so forth. That's how you're able to split it up and end up with minus 4 times by 3. And therefore, that means we can do some simplifying. So apologies, cramming it into the bottom of this slide. 42 minus 7 root 5 plus 2 root 15. And over, that's going to be 49. The minus 14 root 3 and positive 14 root 3 are cancelling out. And the 4 times by 3 has become a 12. Meaning the final answer is 42 minus 7 root 5 plus 2 root 15 all over 37. And then you could even go as far as really cramming it into the bottom of this slide. 42 over 37 minus 7 over 37 root 5 plus 2 over 37 root 15. There you go. That is how you can simplify a fraction that's got square roots on the bottom. And so there you go. That is a quick reminder of surds, surd laws, index laws, how you can manipulate them. Sorry for the rambly explanation in places. I record these videos late at night. Terrible excuse, I know. But hopefully you managed to make sense of some of the things I was saying. But ultimately, if you want to know these things, the best thing to do is to practice them. A lot of these things are rules, and the way you get familiar with the rules is you just do lots and lots of practice until they become second nature. Really important with these sort of more crazy sort of things where you can't rely on intuition quite as much because of the more scary looking notation. So there you go. That's my advice to you, and good advice in general for Maths A-level as a whole. Right then, with that said, I shall see you hopefully in a future video. Goodbye.